Greetings, folks. Scott here, Game Audio Institute, working on the Constellation project still. We're getting closer. We're getting closer. I had this thing where it was quantized position and then it was multiplying by 2.0 from quantized position. That was actually just making it just continue forever and ever and ever going to the right, which we don't want to do. So instead what I did was I put my multiplier in here first, and that seems to have solved the issue overall. Okay, so now we've got something working. The next thing that we need to do is we need to define ourselves a public bool, or a private bool, really. And now we can do this, and we can say also serialized field. Then over here, what we're going to do is we're going to say Boolean. Oh, right. Yeah, actually, now that I think about it, this is the issue. Yeah, we have to look at the position that the other object's on, when it's at the same position. Oof. Okay, so that's going to be an interesting thing, because we don't want to use triggers. I'm definitely not trying to use triggers for this, but we do need to be able to figure out the Boolean for each of the items, which means we have to have a list. Yeah, we have to have a list of transforms, I would guess. So we're going to also then, we're just going to go back and put that serialized field back in there. Instead of Boolean, we are going to have it be something that understands the position. But yeah, let's go check this out. So this would be a transform list. Transform list. Row. I'll call it sequence row. Sequence row. And now that we have that in there, it will be a exposed parameter. And in fact, we'll probably need to have both the play position so that we know what position the object is, as well as its actual location, which is the actual location where we're moving the playhead, which is fine. We can do that. That's not a problem. So our playhead is here. Our sequencer control is there. What we want to do, sequence row, right, is take all of those sequence row objects and dump them into here. Now we're going to do a very, very basic kind of thing. We're not going to have them click on or anything like that. We'll deal with that in a little bit, but I just want to basically make it so that if I have a mesh renderer off, then it will not listen to me. Oh yeah, hang on. Gotta go with that there, and probably lock the inspector, and then grab all of those objects. Hope they are going to be in order, but I can reorder them if I have to. Now, what happens? Yes. Int grid position equals int my position. This is fantastic, actually. Then in this case, we can use grid position to determine the actual sequence point, which will be ideal. That's what we really want to do. So now what we want to do is send grid position to some value called maybe check position enabled. How about that? Check position enabled. The input value will be into here, which will be an int position. Cool. And then position, grid position equals position basically, or it would be fed into that sort of thing. So we'll say check position enabled. Position enabled. And then would be grid position. Grid position. There we go. Oh, the only thing I do need to do is make sure that grid position is always going to be here. I'll do this. We could potentially do sequence length, but sequence length is almost always going to be 16. But anyway, I'm just going to say grid position modulo 16, which basically means it's going to keep just repeating over 0 to 16, essentially. Then we would basically be running through this thing, and that every time you hit the position, and then you would just simply say if, what we're going to say, the game objects. Okay, so it would be sequence row, right? Okay. If sequence row position dot get component. Actually, I don't even think I need to say sequence row dot position. I could just simply say, because we want to have a renderer. We're going to deal with the mesh renderer. So we'll go mesh renderer equals mesh renderer. Oh, sorry. I'll just say renderer. Right. Mesh renderer. And we can potentially, since it's a private variable, local variable, whatever. Mesh renderer equals right, it's a transform, right? That's easy. So we'll just say it's sequence row, sorry. Sequence row sequence row position, whatever that is. Yeah, position. Dot get component renderer, mesh renderer, whatever. All right, so now we can have the if statement, and we can say if renderer not null, if renderer does not equal null, right, then we would go to the next statement, which would then also say, yeah, then all we have to do is this. We just would say renderer enabled, right? So we go underscore renderer dot enabled. Actually, we do this. So say enabled equals is assigned to whatever the state of renderer enabled is. Copying things over, of course. It's not. And that should do it. Right. And then enabled will switch on and off depending on whether our mesh renderers are enabled or not enabled. And we can make a situation where if we click on the mouse, then we can enable or disable the object or whatever. That's fine. That's easy to do later on. So we're just trying to check this. Check position enabled, grid position divided by 16. We could also say by sequence row dot length if we wanted to do that. It doesn't really matter, but if we're planning on changing the sequence row dot length, that's probably not a bad idea. So let's do that. Sequence row dot length. Actually, we'll probably just use a variable that will be our actual sequence length. Check position enabled, sequence row dot length. Okay, and we'll probably have to do some other kinds of things too. But you know, this is just trying things out. So check position enabled. Okay, got it. Now what we want to do is we have defined these things. So we want to now define global. Now I don't know whether this is going to work per instance. It could be better as do as local, but we're going to say this global Boolean. Is it a Boolean? Well, no, yeah, I don't know whether I have to look into my Chuck data, but let's say global Boolean enable note. Let's just say that enable note. So a global note Boolean enable note. Now I have to think about how we get values into Chuck because that's the main issue we need to do. We need to be able to convert this value and send that value to Chuck. So go sync float my position Chuck. Okay, at some point there was a send float value, wasn't there? Set float, time step. Okay, so we're going to say, actually, you know what? This is going to be not a Boolean. This is going to also be a float. It could also do an int, actually. Let's do an int. Global int, enable note. That's fine. So now we have our value that we're throwing into there. That's called time step. There was a time step. Was there not? Oh, there was not. Oh, yeah, there it is. Global float time step. Global int enable note. So now I am going to say, instead of set float, I'm going to say my Chuck dot set int, I would imagine. I would hope that that's possible. We'll see what happens. Int, unless it's only a set float object. I don't know. Maybe it only does work with floats. Set int is going to be called, what was it? Enable note. So set int enable note, and then which I guess would be the value of new times. No, that would not be enabled. I think it would be enabled. Enable. Right. And enable is an integer, right? If this is possible to do this. So the value is either 1 or 0. So I guess we would say this would be int state. I'll say node state. Node state equals. It's kind of weird because it has to basically set to the value. I wonder if we don't want to use a Boolean. It'd probably be easier not to use a Boolean, actually. Okay. So in that case, we would change this. Right. So you'd have to say if render doesn't equal null, then you'd say enabled. So instead of you say, so instead of Boolean, we'd say what? Integer node state? Okay. Then we would say my chuck set int enable node, and this is going to be node state. Right. And node state will be changed. It will be set by this value, which is being called every single time on the grid, although it's being called later. So we could potentially, I suppose, check that out. Let me think, was it get current value? What did I say? Check position enabled. That's what I said. So let's do this. Let's take that and stick it right after the float. Just in terms of order of operations, it might be a better idea. Okay, so now we have to do this. So it will always have to update the position. So you would be saying if enable note is equal to 1, and if it's not any other value than 1, basically that. Okay. I have no idea if that's going to work or compile or do anything. It did not like it. Cannot use local variable grid position before it is declared. That makes sense. Got it. Right. That would be important. Okay, fine. So we'll put that back where it was. It's just not going to be possible to do it before then. So in that case, what I will do is I will move my enable note to after that point. Just in case. I don't know. It's not a big deal, but it's not. I'm just trying to follow the same pattern as this, essentially, as far as what things are going on. So, and I will comment things once I know that things actually work. That's saying system intent pointer. Ooh, interesting. 9131. System int pointer. That's interesting. Okay. It's kind of like pure data, how you can't really set integers, you can only set floats. That's fine to do this. This is all the extra stuff that we're doing in the middle. So we'll just call this set float again. Enable note state. Note state is now technically a float. I still don't like it. Oh, it's okay. So it didn't like, there was no such thing as set integer, unless it's int 32. Maybe it's int 32 or something like that. I don't know. Then what we want to say is node state equals 1.0f, just in case 1f. and 0 is usually 0. And then note state is there. Okay, good. So now, I don't know. We will find out if this even works. But what we want to do is just turn a few of these mesh renderers off. So we will unfreeze that. And in this one, we'll turn a mesh renderer off. And maybe over here, we'll also turn that off. And over here, also turn that off. So, you know, something like that. Okay, so we'll see what happens in that particular regard. If enable node is equal to 1.0f, I don't know whether this is actually needing to be, I think it is, because if it's C# based, it probably does need to be this. Actually, is he saying any Fs? I see no Fs. All right, well, hopefully it won't die out. I don't know. Find out. Here we go. Yeah, it's not doing anything. It didn't like that. So let me go and say this. If enable node equals 1, spork plain out. Now, I think I should be able to do this. Enable node is equal to 1. Enable node is, oh, I said int. That's my problem. Float. It has to be float. Okay, try that again. It's behind. It doesn't actually know what it is. There it goes. Very good. Liking that. Okay, cool. Anyway, so here we go. I guess that's probably a good enough stopping point. It is basically working. You notice that it was kind of off for a little while, and then it figured itself out. It's kind of interesting to see that. You know, I don't know. It's a little bit weird. You know, it's a little strange where it's like the timing is off to begin with for one whole time completely off, then it's slightly off for the second time. By the third, it figures things out and everything's cool. But it is interesting. I'm curious about if it has the same issue with you running it faster. So we did 500, right? Didn't we? Yeah, let's go 250. Let's go to that. Make it faster. I think that's faster. Maybe it'll be slower. I don't know. Probably not, though. Wow. And then it just ran out. All right. Well, anyway, we'll find out why that didn't work well, because that's really important to find that out. Anyway, okie doke. Well, I hope this gets your game audio on here in Unity, and we'll see you in another one once I figure out why this has crashed. But there you go. See you, man.